Plot the following data: time in years, D in dollars. Time is the variable that's going to behave like X, D will behave like Y. Time goes from 0 to 14 and dollars goes from about 8 to 26. So how are we going to do this? Well, we should have the x-axis in there, and the y-axis in there. It looks like all the points are in the first quadrant, so draw it like that. And then we have to label our coordinate axes, so 0 to 14. Don't think we can skip one here, so let's just go 7. Yeah, we can't skip. Okay, so there's your 0 to 14. That guy's your 14, and then we need to go up to 25. So I think there's only 20 squares here. Let's go by 2s. Alright, so that's 10. Let's go by 1s, I mean. That's 20. Okay, might be off the graph on one of them, that's okay. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Okay, great. So we need to plot these points. When we're 0, we're at 8.77. So just make something close to 9. Sounds good. Let's do it in a different color here. Green. Okay, great. At 2, I know we went by 2s. Oh darn, that would have been nice. Okay, 10, 5, 3, so halfway between 10 and 11. Oops. Halfway between 10 and 11. 13 at 4. 15.85 at 6. Almost 16. 18 pretty much at 8. And 10 is almost 20. A little bit less. And 12 is 22.5. Halfway between 20 and 23. And finally 14 takes us off the map here, 25.1. Okay, great. We plotted all the points. Determine if there's a positive, negative, or no correlation of the data. When it slopes upward, that's a positive correlation. When it slopes downward, that's a negative correlation. And when you can't really tell ultimately what the slope would look like, when it just seems that the points are just randomly scattered. See, what happens is these points aren't really on that line, they're just randomly scattered around that line. It's called the line of best fit. And so the regression line is the line of best fit. And this is a 0 correlation. Or no correlation. Okay, so we're going to say that we have positive correlation. It's going to, as you move from left to right, as you increase the input, it seems like the output is also increasing. Alright, the line of best fit. That's a calculator thing. We have to enter our points in to a calculator. I'll be using the graphing calculator. We'll enter these into a table, stat, edit, and so the L1 is going to be your inputs, 0, 2, 4, 6, 8, 10, 12, and 14. The output is going to be your D value, dollars, 8.77, 10.53, 13, 15.85, 18.02, 19.81, 22.25, and finally 25.1. Okay, great. We want the line of best fit. Let's quit out of this and stat, arrow over to calculate number 4, linear regression AX plus B. We hit this, it should tell us the slope. This is the y equals mx plus b. And so we just write that down. Let me just take the screenshot over to the thing here and paste. Okay. There we go. So the answer to this question, I'm not quite sure if that's what was intended, but it works out well, that y is equal to 1.16375 times x plus b, 8.52. That's the line of best fit. That's a line that will come up and pretty much fit this. They don't all land on that line, but it's called the line of best fit, the regression equation. Alright, and that is all.